All right, I'm going to solve this problem right now. It says an object moves in the positive direction with an initial speed of 9 meters per second. So do I have a y component here? It's just moving along the floor, right? So we have just an x component, one-dimensional motion, right? So v naught equals 9 meters per second. Okay. The surface is flat and there is no friction, so we don't have to deal with friction. At t equals 0, a force at t equals 0, force at t equals 0, or the force of t, f of t, okay. F of t, and that's at t equals 0, equals 5.00 newtons per second squared times t squared. So you can see your force is changing with time, right? You see that, right? But the mass is not changing with time, right? So that means your acceleration is changing with time, correct? All right. So this is the applied, and it said applied in the negative direction. So I have to do this, right? Because I've called that positive. So I have to do that. To the box, okay, the box weighs 29 newtons. Okay, so weight equals 29.6 newtons. All right, so we already know that we don't have a constant acceleration, so what does that mean? Can I use my kinematics? No. I'm going to have to integrate, right? All right. And I'm given the force, right? But my integral, I'm going to want to do v equals the integral of a dt, right? That's not a. See that? Did you guys catch that? Good. And I've got the weight here. So I want to get my mass is my first thing I want to get. All right. So mass equals weight divided by g, right? Because mg is weight. All right, so what would that be? So mass equals 29.6 newtons divided by 9.8 meters per second squared. And what is that? Anybody have that? I don't have my calculator. Do you mind doing that, please? Thank you. Negative 3.02 what?
Wait, positive.
Positive, yeah, all right. 3.02 kgs, right? Because a Newton, look, a Newton, we got a kg, meter over second squared, divided by a meter over second squared, right? We know the units of newtons is MA, mass times acceleration, right? So we have a kilogram, meter over second squared, divided by a meter over second squared. So we do indeed get the correct units. Great way to check your problems, right? Do your units work out? We had you with a feasibility test, remember yesterday when you forgot to put the C in front of the M? No biggie, it was just a mistake, right? So that's another one. Feasibility test and units. Two ways to check your physics problems. All right. Don't mean to call you out or embarrass you or anything. Yes, ma'am?
What does G stand for?
Gravity. Yeah. Okay. All right, so now we know that our mass is 3.02 kilograms. So in order to get A, F equals MA, right? So F divided by M equals A. So I'm going to go ahead and do that. I'm going to have my F of T divided by M equals negative 5.00 newtons over second squared times T squared divided by 3.02 kgs. All right, so let's look at this for a minute. Let's, what is the, does anyone have the value of 5 divided by 3.02?
Negative 1.655.
Okay, negative 1.655. What are my units going to be? Newtons over second divided by kg? That's clumsy, right? So if I have a newtons, let's do kg, meters per second squared, and then that's the Newton, right? Now I've got that term. So I'm going to do a 1 over second squared, right? And then I'll divide it by a kg. So that'll go, and my units here are meters over seconds to the fourth, right? And then I've got a t squared. And that makes sense. I've got an acceleration. Oh, I'm sorry, seconds to the fourth. Sorry. That makes sense. Now I've got my acceleration. I've got a second squared here, seconds to the fourth there. So now my units will work out for my acceleration as well, right? Meters over seconds squared. Can you see that, Christian? Is it too low? No. Okay. All right, so that's pretty perfect. So now we have A of t equals negative 1.6. I'm going to go with 6, right? Meters, seconds to the fourth, times t squared. Okay. All right, are we done? We're not done yet, are we? Okay. All right, so the problem is asking for how far does the box move from its position at t equals 0 before coming to rest? All right. So may I erase all this work right here? I need a little bit of, I need some real estate. You guys good if I erase all this? Good. Okay. All right. I have my acceleration here. I need to know how far it moved from its position at rest, right? Or no, at t equals 0. It's not at rest at t equals 0, is it? From the problem, well, do I have a velocity at t equals 0? Yes, in the positive direction, right? Okay, so let's, we're going to have to get a function for position, all right? Okay, so so velocity is going to be equal to the integral of a dt. All right, so velocity equals the integral from t1 to t2 of negative 1.66 meters seconds to the fourth times t squared. Okay, now to take that so v is going to be equal to, I'm going to bump that up to a cube, right? So I got to divide by the cube. So I'm going to say negative 1.66 meters seconds to the fourth, and that's going to be over 3 times t cubed plus c. All right, we're going to get c from our initial conditions. So I know that this is our velocity function, and I know that at t equals 0, v at t equals 0 is 9 meters per second. Okay, so let's go ahead and v at t equals 0 equals 9 meters per second. So I'm going to go ahead and equals negative 1.66 over 3 meters seconds to the fourth times 0 plus c. So this term goes to 0. So now I know t is 9 meters per second. So in the future, you just take the initial conditions. You really don't have to do this step, but you take the initial conditions to get c, right? So now I know c is 9 meters per second. So I'm going to take my equation here and call this 9 9.0 or just 9 meters per second. All right, so far so good? Am I ready to stop? Yes, ma'am.
Why did we choose T1 and 2?
It's just, I just write this because isn't that how an integral is written? These are the...
You can write it without them.
I can?
Yeah.
Okay.
You just mean like A and B, right?
I'm just, yeah.
Okay.
Well, I mean, the first, time 1 and time 2.
Okay.
Yeah, we're actually solving for time 2, right? Yeah, that's what we will be solving for.
And then where did you get the 9 from?
The problem is, read the problem, it's given in the problem.
But why did we put it there?
Because I know that v at t equals 0 is equal to 9. The problem gives us that. Okay? So if I have 0 here, right? This term goes to 0, and I know v is 9 then. So this is my c, so c's got to be 9. Okay? Clear, everybody? All right. So you get your c from the initial conditions, right? So you get your, in physics, doing these problems, you get your c from the initial conditions. All right, but I'm not done here because I'm not looking for a velocity. I'm looking for a position. Okay, so and my position function I will get from what? Integrating the velocity function, right? So x equals the integral of v dt. Okay, so x equals the integral. Do you have a value for 1.66 over 3?
Negative 0.552.
It's negative 0.552 meters seconds to the fourth times t cubed plus 9 meters per second. Okay, so I'm going to erase that. Okay, so now integrating this, what do I have? X equals what? Add 1 to the exponent here and divide by that, right? So it's going to be equal to negative 0.552 meters seconds to the fourth over 4 times t to the fourth plus 9 meters per second times t. The exponent here is 1. So I divide by 1 there, it's just nothing, right? It's 9, right? Okay. Plus c. Okay. My initial conditions for c, the problem is how far does the box move from its position at t equals 0, right? How far does the box move? It just wants a distance. It doesn't say we started at x equals 5, right? So we can call, that can be initial condition, we could call it 0, right? Is that clear, Brianna? That c is 0 here?
Because the position.
Because the position, initial position at t equals 0 is 0. Good. All right, so I don't need a c here. All right. So, oh, wow. Okay. Here's the thing. Now I forgot to do the one step. I hope I didn't. That's the velocity function. Okay, how far does the box move from its position at t equals 0 before coming to rest? So now I have my velocity function here. Negative 0.552 meters seconds to the fourth times t cubed plus 9 meters per second. I want to know how far the box moved before it came to rest. Now you see it will come to rest because we start off with a positive velocity, but we've got this negative acceleration here, right? Right? So it will come to rest. So I'm going to solve for that. So I want to know the time. when v equals 0 now. Okay? So 0 equals negative 0 negative 0.552 meters per second to the fourth times t cubed plus 9 meters per second. All right, solving that for t, so negative 9 meters per second divided by negative 0.552 meters seconds to the fourth equals t cubed. Take the cube root of both. If someone would be so kind to do that. Yes, ma'am.
Question, where did the 4 go in the denominator?
Oh, sorry. Thank you.
No, on the, right there.
Here?
Yeah.
It's still there.
Like on the other, when it's being divided by 4. And the bottom?
Right here?
No.
Oh, yeah, that's because this is the velocity function right here, right? I mean, this is the position function right here. Yeah. So when I integrated, the exponent went up to t to the fourth, and I need to divide that. These are two different functions. Okay. All right. Does anybody have a value here? Somebody, yeah, do you have it?
2.54.
2.54 seconds. So now t equals 2.54 seconds. T is 2.54 seconds before the object comes to rest. All right. So now I want to know how far it went in the 2.54 seconds. Okay, can I erase some of this? Would you like some time to... You guys are all good? Okay. Absolutely do what you need. Okay. All right, so we'll lose this solving for t. All right, but we know t is 2 point. So now I want to know a distance. I'm going to take this function, and I'm going to pop in 2.54 seconds, and I will solve for the distance. So x final equals negative 0.552 meters seconds to the fourth divided by 4 times 2.54 seconds to the fourth power plus 9 meters per second times 2.54 seconds. It's a very nice problem. If somebody could get that for me. Will you do that, Allison?
17.1.
What did you have?
17.1.
17.1 meters? Okay. 17.1 meters. Is that correct, Allison? All right. Okay, we could turn it off now. Thank you.